So you just watched the launch. What do you think?
Well, it got up, the booster exploded, but the payload detached and everything seems to have been pretty nominal, plus an explosion, which is kind of, that's what it went well.
We're getting an explosion on top. Okay, wonderful. Well, this is the final back-to-back session of the panels, and we're going to start off with space, and there will be some energy in there too, and then we're going to launch into existential hope. And that will be mostly about positive visions of the future, including specific funding and institutional architectures with which we can make that happen. Okay, so again, I'm starting us off with a quote, again from Eric Drexler, again from Engines of Creation, the book that led to our founding in 1986. Whether anyone else is out there or not, we are on our way. Expansion will proceed if we survive, because we're part of a living system and life tends to spread. Pioneers will move outward into worlds without end. Others will remain behind, building settled cultures throughout the aces of space. Where goals change and complexity rules, limits need not bind us. All right, that is an appropriate start, I think, into the panel. I'm so happy to have Anders here, who we've already met on the Neurotech panel. Anders is currently writing, I think I call it the book of all books, Grand Futures, which will basically contain all the possible books available, and with a very, very big section on space and our long-term future in space. Robin has recently just gotten out with an incredible theory about when we're going to meet aliens, at least the grabby ones. So we hope to talk a little bit about that. Andre just arrived, jumped out of the cab, and is here now. Thanks a lot for coming. And you're with Jedi and really focusing on making innovation happen across the board. And Mike Gibson with 1517, same deal, really focusing on trying to get innovators to innovate more, especially the youngsters, which I find very exciting. All right, well, let's dive right into it. Can you bring us up to speed on a specific technology? It can be energy or space that you're particularly excited about in the next 5 years and where you think it could get us. Give us a little bit of a glimpse of the future.
So to reiterate what I said in the Neurotech panel, being able to rapidly iterate on your technology, trying out things, having them blow up, learning stuff, is obviously the key for making prices go down in any domain. This is why I'm rather bullish on space right now, because SpaceX and others are now iterating like crazy, and we're hopefully going to see people iterate on the many space technologies, which is going to be needed for actually trying out space mining, space manufacture, and a lot of those things. This is also why I'm strangely not as bullish on fusion, even though it looks like fusion is going fairly well right now. It's just that the scaling means that a bigger fusion reactor is a better one. So you want to build a few really big set of fusion reactors. And unfortunately, that means now you don't learn that much when you build the next one. So those scaling laws don't work in your favor. And we might indeed end up with fusion being an excellent energy source, but as tied up as nuclear fission. So iterate.
I'm really impressed with SpaceX over the last 10 years. I mean, as most everyone else should be, right? 10 years ago, expectations were vastly below what they've achieved. So hats off, spectacular. They made 2 big bets in a row. The bet on being able to do big space launches in large capacity and frequently, and the bet that they could sell that to make money through their space internet, which I guess they seem to be making a go of. It seems to be working. I'm not sure. I'd love to get data on that.
There's a Starlink out there.
Right? Yeah. Okay. And But will they make a profit on this in terms of what price can they sell? I mean, there's some people willing to pay a lot in rural, strange places to get internet, but can they really sell this to, most ordinary people? I'm not sure about. I wish I would know, but still, they seem to be making a go at that. The next market after that, I'm just not so sure there is one, but they're making these 2 work, and that's spectacular, and hats off, and I'm really impressed. And even if they just waste money on a bunch of other things that don't make money after that, they will have enough money to waste, and we will see some cool stuff.
So what can I say after that? I would focus on 2 concepts. One, the concept of interdisciplinarity. Everybody talks about it. Nobody really does it. It's not valued in scientific research. There was this fantastic sentence, it's not about space or energy, which is from Kathleen Carrico. Kathleen Carrico is the one scientist that was for 15 years working at Penn State with almost zero money on RNA. She just got the Nobel Prize for her work. And she told me just a couple of weeks ago, it's incredible, for 15 years nobody was banking on RNA. Now, if you want to develop a vaccine which is not based on RNA, you don't get money. So we keep repeating the same problem again. So one, interdisciplinarity, because you see a lot of the real breakthroughs are happening at the intersection. And how can we do it? I mean, that's why I'm so excited about what you do, Alison, and this institute, because we need to be deeper and deeper and at the intersection, but things are really happening at the intersection. Let me give you some examples, not to stay too general. One, on fusion, I kind of agree, but I think we also need to bet on the few things which are bottlenecks. And right now, be it on laser or be it on magnetic, the issue is the container. Today, we have not identified a container that is resisting the radiation that is actually emitted by a fusion reactor. And so if we're not able to do that, obviously we will have a problem to scale it. Many others, but I think this is one of the key ones. The other thing on space is, but that's more from a European perspective, we always start with the hardware and then we build the software on top of that. And I think if we can build more software-centric, and that's the whole story about Tesla, if we can do software-centric, and then be much more reusable, versatile, adapted to the mission. I mean, the number of objects we are launching right now, obviously, if we don't make them reusable or reprogrammable, I mean, we're going to end up with the same kind of waste and waste management that we have in low Earth orbit than we have on Earth. The third thing I would say is on energy, I would focus on storage. I mean, how many of you have not used your storage device for your phone since this morning? I guess a very small minority. And when you look at the curve of improvement of storage, it's really one of the big areas where we failed in the last 20 years. I mean, the progress has been very low. And so I have high hopes that what is storage all about? I mean, when you talk battery in particular, it's a cocktail. Anode, cathode, electrolyte, etc. I don't think we're using enough the power of AI to kind of scale that kind of combinatory aspect. And moreover, think about what science is. Setting an hypothesis and then testing it. Are we really going beyond our cognitive capabilities by setting hypotheses which we don't even think of? And I think that is probably the power of AI applied to a lot of our scientific areas. And then test combinations. I heard a couple of months ago, IBM announced a new battery. I don't know how much it was hot air, how much it was serious, but I think we're going to see also very different players enter the storage space. Thank you.
Great. Yeah, I maybe as an investor, I focus on the economics of the space industry. SpaceX is clearly the leader. With the Falcon 9, it's something on the order of $800 or $1,000 per kilogram to launch into orbit. The promise with Starship is to get that down to $200 per kilogram, which is quite extraordinary. What we've seen in so we do invest in companies started by people without credentials, but we break that every so often in the name of science fiction. We've made a number of space investments. And with that decreasing cost of launch, we're starting to see startups it's now a platform for them to experiment in ways they couldn't in the past. It's much cheaper to get that initial satellite or whatever up into space, and therefore now we're starting to see some wild ideas. In our fund, we've invested in dual-purpose technologies. I just heard a pitch last week for a team that wants to launch a giant mirror or set of mirrors into orbit that would allow them to target solar rays to farms or solar farms on Earth, which is kind of wild. There's another company we backed. They're looking to replace GPS, which seems like a miracle, but is very inaccurate when it comes to locating your taxi between two roads, or it's insecure because it's very hackable. So we're going to start to see more and more experimentation because the cost of launch is so low, and that gets me excited as an investor.
You already mentioned this to some extent of like, okay, we can do, the next thing is pretty exciting right now, but then what after? I think like tying, the current successes together with the visions like this, it seems like kind of like a big stretch. Like, after we've perhaps like, pivoted out on like what SpaceX is doing right now, what do you think we need to kind of like invest in more? Do you think asteroid mining makes any sense? Do you think solar sails make any sense? Like, what is kind of the next step that gets us beyond it if we even should go there?
So this is the funny thing, because I'm of course an exuberant long-term optimist, but I'm thinking, oh no, this is the valley of death. This is actually the real problem, because how do you make a good business model in space? This is where I think Robin and me are going to be the grumpy old men saying, yeah, please show us a business model that actually makes sense beyond Earth orbit. Asteroid mining, great. There is a lot of stuff out there, but it's very widely dispersed. It's not in good ore bodies, most of it. And getting it down to Earth, that is as expensive as launching something equivalent to Earth, from Earth. Oh, it's mostly useful up in space, but for it to be worth anything, you need to have a lot of space industry up there that's supposedly producing stuff for who? Getting this to start seems to be a really hard starting problem. And I think that it's going to be a long while before you actually get something self-sustaining. Long run, of course, once you have automated mining and manufacturing, you can do endless things. I got a little Dyson swarm here. I want to have a Dyson swarm. And yeah, it's thanks to him and the wonderful people at Olfen. And I think, again, if we can settle space, if we have all the tools for automated manufacturing, automated mining, really good recycling, really good closed ecosystem. First of all, a lot of the problems on Earth that tend to motivate people saying we need to go to space, go away. We have a lot of resilience on Earth. It still might mean that by that point we're so rich that some vanity project, some crazy project or ideological project have a chance of creating these new settlements. And I think eventually that happens, but that's a long-range thing. So one aspect is lowering the thresholds for innovation means that people can try out important things and we learn these things that make that value of death shorter. And it might also mean that we learn other useful things. But I think it's tricky. Real long term, once you have reached the technological maturity that you can use the dispersed energy and matter in space, then you're a mature civilization. The existential risk goes down tremendously. Once you're on the Dyson sphere stage, you don't need to be too worried about the other civilizations even coming and taking your stuff, etc. That's a separate discussion, but there is kind of, that is a goal worth reaching, but the business model of reaching it seems hard. And that's where I would turn to an economist.
3 ages of space. There's near-Earth space, there's past near-Earth space, but mainly depending on Earth, i.e. selling things to Earth and trading with Earth, and then when space could be self-sufficient without directly trading a lot with Earth. That third stage is a lot harder than the second, and we aren't to the second one yet, and unfortunately, there's a deadline coming up. I'll talk more about it tomorrow, but basically the world economy is going to peak in the next half century to century and then start shrinking as population shrinks, and then we might desert our space partners as the world Earth economy becomes less able to support the space economy because we're just smaller and want to buy less stuff from them, and that's a problem. If we don't reach the self-sufficient space by that point, we may lose the second stage as well.
Let me come back on the interdisciplinarity aspect. You probably all saw the Indian probe on the moon, and a couple of, I think it was 2 years ago, the Chinese landed on the South Pole. What is relatively well known now is that on the South Pole of the moon, we think that there are reserves in helium-3, which are in the order of magnitude of 100,000 tons, which is probably 100 times more than we have here on Earth. Is it a coincidence? I'm not sure. So thinking of, and then lastly, look at how much nuclear propulsion is again a little bit, not so much in Europe, but in other parts of the world, thought about again in terms of, interstellar space travel. So I think putting these dots together, I'm not so sure, if we had a source of energy which we can produce far from the Earth, with a production site which is probably much more profitable to manage than what we try to do here on Earth. And then with that, we can then launch more expedition. I mean, I'm not so sure we always put these 3 dots together. So I think that is probably something which is still probably not worth for an economist. And by the way, we announced peak oil 20 years ago, right? So I'm always worried about when people say peak, because unfortunately, or luckily...
That wasn't economist.
Okay.
Somebody else.
So I would think it this way, actually. The think of energy and of the topic of energy and of space is deeply connected. Last but not least, I cannot stress We are still in 90% of the startups I see, or even in the scientists that work in space, with this idea that what you launch in orbit needs to be very small, very adapted to a small capsule. I think Starship is going to change completely that mindset. I mean, where tonnage, weight is not anymore that limiting factor, and even not also the size. And I think we really need to think out of not the box, but of the nacelle of the Starship.
There's an old joke that two economists are walking down the street, and one sees a $20 bill, and the other says, "Don't bother picking it up because markets are efficient. If it was real, someone would have picked it up." So let me pick up the $20 bills lying in front of us. There's a lot of garbage in space. Old satellites whose orbits won't decay. And we have seen a number of companies, one that we've backed, which is trying to create a way to catch these pieces of garbage, capture them, repair them, disassemble them, and so on. That technology certainly could be profitable in the short term, and the capabilities gained in the course of doing that will enable them to catch asteroids as well. There's one approaching Earth, I think it's called Hypothesis, in 2029. This company is working with NASA right now to create a mission to deflect that asteroid, maybe even work with it in some way, we'll see. So I think there is a way to climb this rock face and make a profit while doing it.
There is one asteroid mining company that I know of that actually has a business plan that hangs together without me laughing. They're named Offworld, and they right now have got actual mining robots down in a mine in South Africa. They're mining platinum in this really deep, really awkward mine that humans don't really like. Why are they not trying to launch something to Apophis? Well, the reason is, of course, you first need to be pretty certain that you can make a mining robot that actually works and is actually profitable enough to mine platinum. The goal after that is a mining robot that can do something cheaper, like gold. And then gradually you move down the chain towards you have something that could actually work in normal mines, and then you move to garbage dumps, and then you start thinking about lunar mining. And finally, after that, you go to the asteroid. So the interesting thing about their business plan is they realize that we need the technology to be really good, and we need to iterate on that in order to get up there. Sending the mission to Apophis and having a deadline when it's last coming by, that's going to be tricky. And I'm worried about a lot of these business plans because they make sense maybe from a physical standpoint, but they don't make sense from an economic standpoint. You want to bridge that. Getting space garbage, for example, who's paying for that? If we had an insurance regime that meant that you need to pay a lot of penalty for leaving garbage up in space, then there would be an incentive. But right now we don't have that. But maybe we should try to make that.
I don't know if someone wants to reply.
So you know there's all these silly calculations where they find some asteroid and they have so much titanium and they multiply the mass times the current market price to some crazy number. And so let me just tell you, like, there are diminishing returns on prices. As the volume of this stuff goes up, the price will come down. So that's a big problem for a lot of this. So I love to see the size of Starship, and I love to see that if you could fill that thing with customers, you could sell it for $200 a pound. But I wonder, like, okay, how many customers can they actually get to fill that thing? I mean, the rockets they already have are fine for filling up Starlink. I don't think they're going to get 100 times more satellites up there for Starlink. I don't think they can satisfy that many more customers. So what the hell are they going to fill this?
This is the beauty of capitalism. I mean, we have investors pouring money in the startups who are claiming they're going to achieve, all sorts of things that we're debating. I don't think it's up to us to sit in armchairs and decide what will and will not happen. I think we're just going to see it play out, and there are optimists and pessimists, and
I
we'll see
do
what
think
happens.
that iteration, experimentation, when it's cheap enough to come up with the crazy ideas for what would be the killer app, that is a chance of actually finding what is really valuable. The internet seemed to be useful for sending files and email, but actually cat pictures and pornography turned out to be a real killer app. And then people built more stuff on top of that infrastructure. So I think there is a chance here, and it's very hard to predict. I think that's another known economic factor, that markets are actually creative. But I think just because the physics works out doesn't mean the business works out.
So let's actually talk about that a little bit. Like, what kind of like regulations or what kind of like policy interventions or policy incentives do you think could make this where you be like, okay, I'm a little bit more optimistic now? Or if you think that, I mean, you mentioned the insurance regime, you know, there were some ideas of like, you know, maybe we just all get a fair share of the rest of the universe that gets distributed to everyone as a UBI in an inheritance day. I think there was something that Mark Miller came up with, Mark and Eric actually came up with a long time ago. I think it was more of a universal capital that you would get it once. Basically, you get anything that we could possibly reach, you get distributed, and then people that would want to mine it eventually could buy it off from you. So, like, what different regulatory challenges do you see? What different regulatory, like, kind of like even like problems do you see once we're on the moon? Right? There's a lot of like, there's a lot of like property rights issues potentially. What do you think we can expect in terms of challenges or in terms of policy innovations, like in the space industry?
So today, SpaceX demonstrated an intercontinental ballistic missile. A private one. The payload is not particularly explosive, but yeah, if you can put something in orbit, you can of course have an Earth intersecting orbit and put something nasty into that. You have a lot of security implications for any mature space technology. Once you start deflecting asteroids, cool. Now you can really talk about a slow but rather impressive weapon of mass destruction. Governments and people are going to want to be involved in creating a framework for doing this safely. And most of the problems are not going to be the dramatic missile-like ones. They are going to be the space garbage or insurance. Or if somebody hits somebody on the space station, what jurisdiction applies. And the problem is the current space treaties are all based on the assumption that it's great powers that do space, and it's all done by very essentially militarized people. It's not done by private organizations. And it's clear that needs to be changed. Everybody is noticing that. Nobody really knows what the framework is going to be. But it's going to be very fluid for the next few years. The problem is we have an international system that's not exactly keen on cooperation. So we might end up with a few competing systems instead. And sometimes that's a good thing. Sometimes that's going to be just, okay, we get something like the law of the sea. Maybe we can just generalize the law of sea and be happy with that. But we might end up with Liberia-registered space craft. We might find that Luxembourg becomes the largest nation in the solar system because they've got all the asteroid mining companies.
Any other spicy takes on regulatory policy issues you want to see or you think?
Well, I think what's happening in space, when you look at these old, I'm a big Western movie fan, and it very much resembles what happened in the 19th century in the US, where basically you had these settlers running west. The first one that was putting his claim was getting a piece of land. It was Wild West, obviously. And what began to actually structure that is when large powers, in this case the US, began to create infrastructure like railroads. So we need to think, how do you keep this creativity, this nudge to kind of, you know, go further, go faster, while trying to create some kind of boundaries because I'm always a bit worried, especially on this side of the Atlantic, when you begin to regulate things, then you kind of happen sometimes to shut down a lot of innovation. So I think the infrastructure, so we need to think about what are infrastructure. I think the waste management aspect is an infrastructure. Maybe the way to, there are amazing numbers of science fiction things about this space lift. We need to think about this way of kind of making that almost a public transportation. I mean, that's not so far away from that. And then you can and leave a lot of room around it. And I'm not so sure for that you need necessarily big cooperation. Look at what happened in Antarctica also in the 60s. You began the power. It was in the middle of the Cold War, but still great powers were able to kind of build a couple of common scientific stations, and everybody could exert its own influence. I think that's something possible.
Everyone, if you have a chance sometime later on, check out the Elon Musk interview where he describes having to put earphones on a seal in order to test the sonic boom, or two seals, yeah. So SpaceX has undergone enormous scrutiny from environmental review. I think down at the Starbase, there was such a massive delay between the two launches because of some eggs cracking. So these types of regulatory constraints are tough. We could point to things like immigration and laws about who can work on what kind of tech. Maybe we should open that up. But maybe primarily I would say let's leave space unregulated. Danielle and I just had dinner with someone who informed us that SpaceX was being sued by a competitor claiming that SpaceX needed to observe the 1972 Environmental Protection Act in space. The court thankfully decided that the United States does not have jurisdiction over outer space. So I think these types of leaving space unregulated could be the best way to keep it exciting and dynamic.
I have no inside information, but I'm about to speculate. Follow my logic. They would not have created and launched Starship if they didn't have a market in mind to sell it to. It's not what they need for Starlink or the other previous markets. The obvious big market is the US military, which I expect behind the scenes has assured them that they will buy a lot of launch capacity because they want to put a lot of big stuff out in space, and they will have a close working relationship over the next decades. They don't want to make this public because they get a lot of benefit from being the cowboy, frontier, independent people, but they're actually going to be primarily funded by the US government, sending military stuff into space, and that will open the rest of space for other things. Other people can launch things too, but the regulatory question is already answered by the fact that they will have a close working relationship with the US military.
At last, we can rely on the government for innovation. Okay, any panel questions before we dive into some manifold questions? Any comments? Yeah, shout it out.
Non-governmentally and you don't have to have $1 billion, not Elon Musk, all that shit. But where is the growth in the space market in the next 15 years, and how do you capitalize that?
So the rockets are the obvious thing that everybody watches because they're cool and phallic and explode and do cool stuff. But it's the payloads, of course, that actually make it valuable. And the payloads right now are a rather peculiar form of engineering. On one hand, it's very high-tech. On the other hand, you also want to use your most low-tech microchips that are very radiation resistant, for example. There are a lot of design stuff that is not super common. And I think that is an area that can be enlarged a lot. Actually, if it gets cheaper to launch stuff into space, it's going to be way more important to do the mechanical and electronic and chemical engineering for that. Or make it software-centric. How do you actually make something that is configurable? So once it's launched, you can write a piece of software to change it into whatever you find out now that it's needed. I think this is where young people can get in, although it might be cool with the cryogenic propellants and all those big things. I think it is the payloads that are going to require a lot of more brains. And I think this is where we might want a handover from the old-fashioned space engineers to the new people. I think there is a lot of cool synergies, both learning the rough and robust stuff that is needed to survive in a harsh environment, and then using the modern ways of thinking about how to create complex systems that are good in complex environments.
And then sell it to the US military.
Well, I think it actually ties in with another question that I also want to ask, which is if you think about other technologies here that we discussed, AI, right, molecular nanotechnology, which is important for material science potentially, right? If you think about longevity, we have there's one company in our longevity track that is trying to do basically using is trying to do more space health for astronauts. Do you think that there's any overlap with other fields that we were discussing here? Do you want to make a request for the molecular machines folks here to really develop much better material science? Or is there any request from a different field that you want to put out there? And maybe
Can I just answer the point before? I mean, we heard that we are heading towards a world where, I don't know if it's $200, but we're actually we're going to have actually massive, think about the logistics system. You have the hub and spoke being built, but then what makes the difference, the make or break if your commercial activity, satellite is profitable or not, is if you have a longevity which is not just 5 years, but 6, 7, 8. When the new telescope was launched, it was so precisely delivered that actually it increased by 1 or 2 years its longevity, which is incredible in terms, because it's pure margin actually, it's a marginal benefit. So I think all these companies who are now helping actually this big logistics to position well the satellite at the right orbit for the right mission, they today are still only a few, and kind of space vans, the ones who are going to the last mile basically on the orbit. And the other thing that combines with actually your question, Alison, is the material science. I think when you look at material, since it's such a regulated environment, what gets into a rocket is still very limited in terms of number of products that you can use. If we can use material that is more resistant to cosmic rays, that can, a new kind of semiconductors that will not defunct. You probably saw in September 2022, there was a massive solar surge that was pretty destructive. I don't know how much from Starlink was destroyed, but I think that there were more than a couple dozens satellites. So I think these areas, I don't know if synthetic biology can help us on that, but that would be this incredible interdisciplinary. I would love that to see.
There is a lot of obvious implications. It's worth noting that Eric Drexler, when he was doing his master's, he was working on space. And then he realized, oh, my solar cells are kind of hard to make on Earth. It would be better to make them in space. Actually, how thin should they be? Oh, only a few atoms. And then he kind of handed over his solar cell project to some other people who are now working on solar cells and said, I'm just going to get back, I'm just going to develop this nanotechnology thing, and the rest is history. So obviously, molecular nanotechnology, from a material standpoint, yes. From configurability standpoint, all of that. I used to think that we wouldn't get into space until we had a quite advanced nanotechnology because it was so hard to build rockets. It turns out, no, you can use stainless steel, actually, if you're clever about it. The same thing goes for biotechnology. If you want to live in space, it's not just that you want to have an ecosystem so you get food. You also might need drugs because medicine and other situations. And suddenly, a chemical factory in space is hard, but we got bacteria and yeast that is really good, and people are looking at ways of reprogramming that. I think that is worth looking into quite a bit. Again, super useful for a lot of other purposes. So generally, this, of course, all works together with any of these interesting technologies. AI, obvious that you can use topological optimization to actually design really cool, really alien-looking rocket engines and other tools, and then 3D print them together. Relativity space is using some of that. So many of these things have obvious, very, very strong synergies. At least these feed into space. The space needs themselves are not obvious that they then feed these technologies, but space has this magic fairy dust effect. People are willing, if I say I want to make closed ecosystem hydroponics for sub-Saharan Africa, people say, oh, that's very noble of you, Anders, but I don't get any money. If I say hydroponics for space, people get really excited. It's the same thing. And it's kind of a useful thing to motivate people. At Alfred, we got better funding for space generation of resilient alternative food than we get for actually fixing disasters on Earth. Okay, let's use this magic space dust.
Just add astro before anything, and it sounds amazing. Astrochemistry, astrobiology. But there was an op-ed in the New York Times. I forget the author's name. They wrote a book called Soonish. This is their latest book. And one chapter is about how we don't know how to have babies in space or on Mars or the moon. So astrogynecology could be a thing. You know, it's like
That's Zach Wienersmith's City on Mars.
Okay, yeah. So look it up. Apparently, yes. So if you're interested in fertility and space, that's a topic.
I think it's worth pausing and noticing that maybe the most interesting thing about SpaceX is as a model for a different way of doing an ambitious business. And that we could hope to see that go into other industries. I think that would actually be a bigger payoff than more stuff happening in space. That is, he really just beat the pants off of NASA and other people in the industry through a very different way of organizing the business and the plan. And I would just have much more hope. Just let's do more of that elsewhere.
Just a quick one. We might be seeing that in fusion, actually. I was down in Culham, south of Oxford recently, and they're decommissioning the jet fusion reactor. The first time ever a fusion reactor get decommissioned. Nobody knows how to do it. They were very excited. They have another one, government run, it's been going for decades. And then there are a few startups moving in, and they don't know how to relate to them, because they're weird people that actually are in business. There might be a fusion X.
A really good segue into our manifold questions. Here's one on a nuclear fusion reactor consistently achieves break-even energy output over a 30-day period by Not many people have voted so far. Please get your votes in. Mostly. Okay, 27% think 2020 and 2025. Then we have 57 for 2030. And then it just goes up. So I don't think people are not quite that optimistic about fusion, really, very much.
But that is running it for a long time. It might be that it's enough to make a quick burst. So.
You think so, for it being economically viable?
Yeah, if you can just sustain a lot of bursts instead.
Okay, let's take this one here. Will space debris pose a serious risk to our human future in space? 48%. Like, if one of you just voted, you could totally flip the vote. Guys, get on money field markets and start predicting. It's important for tomorrow's realpolitik discussions. All right, so we're kind of like, what do you think? Yes, no? Will it be a problem?
Somewhat. Low Earth orbit is... Yeah, somewhat.
I want to answer the previous one about fusion. The obvious question to ask about fusion is, since we've screwed the entire nuclear industry for a half century by not letting it reveal its potential, what's the chance we will somehow allow the potential of fusion to be realized when we didn't allow fission to be realized? What will be different there? That has to be the big question.
Okay, cool. Anyone want to
I think on fusion, the big difference is the waste aspect. So I think that is a massive one. When you see that even the Germans begin to think about fusion and think it's cool, I mean, not all the Germans,
No meltdowns, yeah.
but I mean, and we have to be careful of managing the expectation, because you have a lot of people in Germany say, yeah, fusion is fantastic, there's no radioactivity. So we need to be so much more realistic on that, because otherwise...
Those containers are radioactive. The one you're trying to get rid of, that is waste.
That is exactly that. So this is the point. So if we don't, and a lot of people who support fusion are not, being realistic about that. And I think that's exactly what happened with fission. If we are not obvious enough and clear enough, then people will undermine that.
If you want to hear someone really rant about that, read Where's My Flying Car by one of our previous presidents, Josh Stossel. He goes on quite the rant about that there. Okay, this is one for the very, very far out future, where we detect extraterrestrial intelligent life in the universe by 224. You have something.
I'll say it. So I have this math model with three parameters about where grabby aliens are in the universe. Each parameter is set to data. That model estimates that we'll meet them in roughly 1 billion years if we go out there. They appear roughly once per million galaxies. So that strongly suggests, no, you're not going to see them in the next century. If you don't, I mean, there's a question of how many quiet aliens there are per loud, but you'd need the ratio to be like 1,000,000 to 1 before you have any substantial chance of seeing any of the quiet nearby.
1 in 1 million galaxies, that's your estimate?
Yes.
He has a very elaborate model on
Yeah,
that.
yeah, and I'm kind of a mildly supporter. I might have slightly different numbers, but I also think the universe is sparsely populated right now.
Great. And once we meet them, it will maybe too late to know. Okay, final words from you guys. After we have one final panel on existential hope, which we're really excited for, and then afterwards we're going to have a speaker meet and greet again. So during that speaker meet and greet after the next panel, give us a keyword that people can contact you about and that you would love to chat more about.
Space, as in distance, as a resource itself.
Economics.
Oceans, especially for to boldly go.
To boldly go? To boldly go where we haven't gone before. That's a good one to close out this panel. We're going to meet here now for the Existential Hope panel with a few really wonderful panelists. So please remain. That will be the final panel of today. And then I'm going to tell you a little bit about what's going to happen after, because we have a few really fun breakouts for all of you guys after. Okay, great. We'll do a panel switch. Thank you so much. This was wonderful.